So this is IXL M4, and I've got to do it a little bit different than what I've instructed with you. In the state of Tennessee, we don't worry about this, but IXL is a national platform, which is a big deal. It uses a lot of Common Core stuff, and there is a technicality here, but I have never seen anybody care about it. But technically, when you take the square root of something to an even power, you're supposed to include absolute value bars. And that's worth discussing why. So say somebody asked you, take the square root of, take the square root of a -3 to the 10th power. Now you guys learned yesterday the deal is that we do power divided by root. That's -3 to the 5th. And -3 to the 5th ends up being -243. And here's why those bars are important. It is impossible for a square root to return a negative. It's absolutely impossible. What should have been done, if you were doing this by hand, is you should have figured out what -3 to the 10th was, and then taken the square root, which I hope is 243. See, I was right. But see, when you use those properties of exponents, you're dealing with variables, you don't see the unknowns anymore. So when you start talking about the square root of x to the 10th, to maintain the positivity that has to happen with a square root or an even root, you have to include absolute value bars. You just have to. So we have to say the absolute value of x. I don't think it matters where the exponent is up to the 5th. And this should only apply, and I'll try and miss one on purpose, but this should only apply when the resulting exponent is odd. Because if it was even, it wouldn't be a problem. If I did something like the square root of a -2 to the 8th power, and I followed my little rules, I would get -2 to the 4th, which is a positive 16. So the only time you got to worry about this is when the resulting exponent is odd. So it's kind of different than the way I teach, and like I said, in the state of Tennessee, we don't care about that. So anyways, this is the root of, man, I hope that didn't crash. This is the root of x to the 16th. Now, the square root symbol has an understood 2 on it, and 2 enters 16 8 times. IXL should not complain about this. This is even. I should not have to use absolute value bars. Shouldn't have to do it, but let's see. Let's see if I miss it. X to the 8th. Got it. All right, square root of x to the 8th is next. Again, understood 2, x to the 8th. This becomes x to the 4th. I wonder if I can draw it here. X to the 4th. No, it's not going to let me. So I can go back over here and type it. Brilliant! This one's really easy. For some of you, you may not be very good with numbers, and IXL is probably not going to try and trick you. But you might have to figure out what the cubic root of 1,000 is, which means you might have to go to your calculator and type 1,000 to the 1/3 power. You might have to. It ends up being 10. And then we also have the cubic root of x cubed, which just ends up being x. It is okay for an odd root to return a negative. It's 100% okay for that to happen. So I don't need the absolute value bars. Super. This one's simple. It's going to be 2x all day long. Square root of 625 should be 25x to the 6th. I feel like that's right. Been a long day. Super. I'm trying to see this one. Okay. I like this one. This one's going to require bars a little bit more. So you've got the root of 1024. This is 1024 to the 1/2 power. Actually, let me erase that. Can I erase that? Is that an eraser? Sweet. I've been stuck on exponents all day and I wanted to stick with it. You cannot take the square root of 1024. I don't think you can. I don't feel like you can. I have had a long day. Oh, you can. It's 32. Huh. I have had a long day. A little dumber today. Square root of 1024 is 32. When we talk about simplifying the square root of x to the 6th, the result is x cubed. So it is possible for this thing to return a negative number when it should not. Now, the reason IXL is so concerned about this whole negativity is because when you talk about the world of math, the square root function itself is only defined to return positive things. When we're solving for x, that's when we're interested in negative things as well. But we're not solving for x. So I'm going to say 32 absolute values of x cubed. And I told you this when I was writing this thing out. This little rule about bars only applies when you have an odd exponent. That's the only time it applies. It's really bothering how much math I know at this point in my life. Why don't I use it? Because I know a crap load of math now. 32 absolute values of x to the 3rd power. I really don't think it cares where the bars are. Good work, Milbrath. Simplify this dude. That is the cubic root of x to the 5th. You guys are familiar with your x to the p over r rule. It is the rth root of x to the p. Why I mentioned that, I don't know. Excuse me. Didn't need it. Somewhere else. 3 enters 5 once. Get to pull an x out. By the way, that's odd. What's left inside is x to the 2nd. Because this is odd, you got to bar it. If you have an odd exponent, you got to put bars on it. Absolute value of x and cubic root, I don't know why I wrote square root there, of x to the 2nd. Is that not what I wrote? I guess I didn't type it right. Huh. Let's try this again. Square root x to the 7th. 2 enters 7 3 times, x cubed, that's odd. Wait a second, they didn't care about that on that one, did they? They don't care about that on these. Even there, that's bugging me. IXL just being weird about things. So x cubed, the remainder is 1. I guess because there's something still inside. That's probably why they're complaining about it. I was always taught that if it's odd, pull it out. Who knows? So according to the last one, this should be right. Apparently it is. Isn't that bugging? Square root of 169x to the 6th. That's going to be 13x cubed. Hope you get it. I need to move on up. I ain't got all day here. Level 4, simplify this thing, the fourth root of 81, x to the 8th. And again, if your exponent's odd, it's a big deal. So look out for odd exponents. This thing here, the fourth root of 81 is 3. You know, if you don't know that, you go to your TI-84 and you root top it to the 1/4 power, okay? 4 enters 8 twice, 3x squared. And that's a 3x squared. It's going to be positive. That's probably why the last one that I missed actually was wrong. I think I had a square, but I don't know at this point in my life. Fantastic, Milbrath. Fifth root of 1,024 to the fifth. That's easy. That is obviously 4x. I swear 4 times 4 times 4 times 4 times 4 is 1,024. Obviously. It is an odd root. Bars don't matter. Excellent. The fifth root of negative x to the 9th. And remember, it's okay for odd roots to be negative. It's okay. Nothing wrong with it. All right, so what are we looking at here? Fifth root of negative x to the 9th. We're going to look at that as the fifth root of a negative 1 times the fifth root of x to the 9th. Now, the fifth root of negative 1 is negative 1. And the fifth root of x to the 9th is x times the fifth root of x to the 4th. Because 1 times 5 is 5, add 4, 9. So the final answer here is negative x square roots x to the 4th. Or sorry, fifth roots x to the 4th. Correct. Bump it up another level. Sitting at level 6. Simplify this radical. Square root x plus 8 to the 4th. Oh, I like this one. I don't know why I didn't do any of these in your notes. I really don't know why I didn't. Remember, you understood 2? 2 enters 4 twice. So the result is x plus 8, quantity squared. And the resulting exponent was even. I don't have to worry about bars because if I square something, I is automatically positive. Terrific, Milbrath. Square root of x minus 5 to the 8th. I'm just going to type that one down. Hopefully you agree with me. You're thinking the understood 2. 8 divided by 2 is 4. Correct. Cubic root. This one's going to have some funny stuff going on. I'm going to pull the negative symbol out front. 3 enters 4 one time. The remainder is x plus 6 to the first. So remember I did 3 times 1 is 3, add 1 makes 4, and always pull the negative out. It's just something you do. And it was an odd root. I have no desire to worry about bars, at least I shouldn't. Sometimes I'm wrong though. So let's see if I'm right or if I'm wrong. I feel good about it. Usually when I feel good about things, I'm wrong about them. Apparently I'm still good. All right, so this one, we can do this one kind of, can we do this one in our heads here? Anything cubed generate a 5, 12. 4 cubed, 64. 5 cubed is 125. 6 cubed is 216. 7, 8. It's 8. It is 8. Took me a second. I don't know why it took me so long. But if I take 8 and I rooftop it to the third power, I get my 512. All right? Because of the negativity, negative 8. If I take 4 and divide it by 3, I would have x minus a 5. And now I need that cube root function, because what's left inside is a singular x minus a 5. I'm in the challenge zone. Yeah. This one is there because it's going to need bars. The result is going to have an odd exponent. I don't think you need that master set of parentheses in there. If you take 9, divide it by 3, you get 3 as an exponent. And I should not need a set of parentheses here, but I'm not the computer programmer for IXL. Didn't need the bars. Because it was an odd root to start. Yep, missed it. So why did I just miss that problem? I missed that problem. I can't write on this, but I missed that problem because it was an odd root, and it's okay for odd roots to be negative. Let's see if I can redeem myself. It won't be on that one. It won't be on that one. It would be on this one. All right, so fifth root 729. I feel like it has one. 729 rooftop to the 1/5 power. This took a lot longer than it was supposed to. I was supposed to already be on my way home right now. Apparently I have a syntax error because I'm in a hurry. 1/5. Oh, it doesn't have one. Okay. So I happen to know that 3 to the 5th is 243. And I feel as though 729 is divisible by 243. I was right. I wonder where that line came from. What I do is I think about this as the 5th root of 243 times the 3. And this last part's going to be really easy. 9x plus 3 to the 5th power. The 5th root of 243 is 3. Don't know why I did that. I need to erase. The 5th root of 9x plus 3 to the 5th is going to be 9x plus 3. And what's still inside my 5th degree radical is a 3. And this is my redemption one. Odd roots don't need absolute value bars. It's used so infrequently. The only person who would ever compare about doing that is a person writing software. That is the only person that would ever care about that. All right, so here's my redemption one. Wonderful. It's time for me to roll out of here because I need to get going. I might do one more. That way I don't have to do it tomorrow morning. There is m.4.